Good evening. Good evening. A rare video I am recording during the evening. I wanted to put together a quick video on the Finney article I asked you guys to read for the week. The article is discussing ketogenic diet and performance in endurance athletes. Before I get into the presentation, you guys are going to get a series of questions on both the Finney article and the Ashton article that I put up last week. So be prepared for those questions now, right now. All right, so let's jump into it. So, right, the article is the human metabolic response to chronic ketosis without caloric restriction. That's a key part of this. Preservation of submaximal exercise capability with reduced carbohydrate oxidation. So, what do we know? Well, we know that during high intensity exercise, carbohydrate is our primary energy source. We also know, bullet point 1, that carbohydrate, both glucose and oxygen, are utilized or fully utilized within approximately 60 minutes of exercise, depending on intensity. Could be 45 minutes, 40 minutes, could be a little bit longer if exercise intensity is a little bit lower. So that presents as a problem for endurance athletes who work out for more than 60 minutes. So enter fat, right? Fat, right, we know, is a near unlimited energy source within the body. And I do mean nearly unlimited. You know, I've seen things that say we could exercise for like 10 marathons over. We could exercise for up to 100 hours based on the fat that our adipose tissue being mobilized. So knowing this, in theory, it seems to make sense to explore the utilization of fat for endurance sports as opposed to carbohydrate utilization, especially at lower exercise intensities. So that's where this article came into play. 1983, Finney et al. Started to explore this. So what did they do? They had 5 highly trained cyclists participate in this study. The first thing they did was the cyclists ate what we would call a eucaloric balanced diet. They ate at maintenance. This was typically somewhere between 35 and 50, it should say calories per kilogram per day. So for example, a 150-pound male cyclist ate somewhere between 2,400 and 3,500 calories. And then they broke it down where the first thing they did, just like I've showed you in other presentations, they had 1.7 grams per kilo of protein, and then they broke down the remaining calories from carbs and fat. So this would be considered a more standard diet. Maybe you might call it a high carb diet, whatever. After doing this for 1 full week, these athletes were then pre-tested. This was their pre-test result. They would cycle for 2 hours at an exercise intensity of 60 to 65% of VO2 max, and then after the 2 hours, they were asked to just go as long as possible. So this was time to exhaustion. This was followed up with a ketogenic diet for 4 weeks. Participants were asked to eat less than 20 grams of carbohydrates. They weren't even allowed to eat a banana, right? So 20 grams of carbohydrates for 4 weeks. The key to this protocol is that this was still a calorically balanced state. So what does that mean? This means that they still ate that 2,400 to 3,500 calories, but it did not come from carbohydrates. It came predominantly from fat, right? So they raised their fat intake dramatically in order to actually have enough calories. After the 4 weeks, the participants went through what we would call a post-test, which was the exact same protocol as the pre-test. And the results are pictured here in the table on the right. So going over the results pretty quickly, you could see it should say TE week 1, that's time to exhaustion week 1, and then time to exhaustion week 4 were the results in total time in minutes that the cyclists were capable of cycling. So we know that there was 5 participants. This is their times. So participant 1 had the most interesting results of this study. During the pretest, he cycled 148 minutes. 4 weeks later, he was able to cycle 232 minutes. So he increased his time to exhaustion dramatically on the ketogenic diet. Participant 2 was also probably interesting because he actually decreased his time to exhaustion dramatically. And then the remaining 3 participants both increased, decreased, really just depends on which athlete you're looking for, but none of them were as dramatic as athletes 1 and 2. Columns, what is that, column 4 and 5, we're looking at respiratory quotient. Some of you guys might know this, better know this as respiratory exchange ratio. We can use those terms interchangeably here. And you guys should already know that the lower the respiratory exchange ratio, the more fat utilization is taking place. Typically, we look at a scale of 0.7 to 1.0. So the closer you get to 0.7, the closer you get to a much more predominant fuel source being fat. Right? The closer you get to 1.0, the more carbohydrate is being utilized. So what you guys can see is something that should make intuitive sense, right? Where they went on this super low carbohydrate ketogenic diet for 4 weeks, right? So their glycogen levels were lower, their blood glucose levels were lower, and after 4 weeks, they should, and remember they're training, right, the whole time. This should show a preferred source of fuel now, and that preferred source is fat. So, right, what do you see? Across the board, every single participant showed a lower respiratory quotient, which means that they were utilizing more fat for energy than in week 1. Okay, so the big question is the so what? What does this mean? Now, the results of this study, a few things. 1, the results of this study did not show a significant difference in time to exhaustion pre to post, but it did not show a significant difference either way, in that they didn't improve more on average, or they did not get worse. Hence the title, where we are able to preserve submaximal exercise capacity. Okay, so they didn't get worse, they didn't get better. So this later on spawned a series of studies to kind of investigate this. Well, they didn't get worse. I mean, the big thing here is, well, this was a very low-powered study. What does that mean? It's a small sample size. We only had 5 participants. And I haven't ran the statistics, but I'd imagine if you removed the first participant who had this massive increase, right, you might actually see a significant difference showing that there is a decrease in performance. Okay. Now you could say the same thing if you remove participant 2, there might show that there's an increase, but essentially this means there needs to be a larger sample. So what's happened now since this paper in 1983, there's been a lot of research since then, and largely we've found that endurance performance actually is reduced when you do remove carbohydrates from the diet. There's one study from Burke et al., I forget the year, which did show an actual improvement in performance, a significant improvement in performance, but there's probably, for every one Burke study, there's been probably 4 studies refuting the benefit of a low carbohydrate diet for endurance performance. And at this point in this semester, you guys should know why, right? Why, while in theory it seems to make sense, why does this not work for these like intermediate exercise intensities, these 60 to 70, 75, 80% VO2 max? right? Mostly because there's too many steps, too many enzymes, there's too much going on, and it takes too long, right? It takes too long to absorb, mobilize, and utilize fat for ATP as compared to glycogen and glucose. Bottom line, right? So that's it for this video. I just wanted to keep it short. If you guys have any questions on the topic, let me know.